the last two examples. So I took the time to put label my x and my y-axis because I know that that does not change. Okay, the first thing that I must do is I must look to see where the middle of the graph is, my vertical displacement, which is 2. And so I'm going to put a dotted line on +2. And then it tells me that I'm supposed to look at my amplitude. My amplitude is 0.5, which means I'm going to be at 2.5 and at 1.5. So again, I need to put dotted lines there as well. Oops. So it's set. And so my graph is going to fit into this narrow little location here. I got to move that one down maybe a little bit. Okay, so that's where it's got to fit. I have to ping pong between those 3 lines. Okay, so sine starts in the middle, and we'll do it in blue, and we'll make it a little bit thicker. So it starts in the middle, ping pongs up at 90, 180, 270, 360, and back up again. So I'm just ping ponging back and forth between here, and you can see that it's not really that difficult. Okay, so we have all our points, and it's a matter of drawing a smooth curve as best we can. And I'm going to get a little bit better at this maybe. And you can see that it looks like a sine curve. It just looks like it's been squashed vertically and it's been moved up. Okay, and I got to make it come up before I can put my arrows. Okay, so that part's done. So the next part it asks us to do is to state our domain. So again, notice our domain hasn't been changing, and actually it will not change for our sine function the way we're doing it. And our range is also a real number, and it also does not change. It's what part changes is where it ping pongs, such that, so y fits here. It's got a low number and a high number. Our low number this time is 1.5, and our highest number is 2.5. Our amplitude here is 0.5, and our vertical displacement was up 2. Okay, so that's that one. Let's go take a look at the next one. Okay, so the next one, again, my axes are labeled. I look first of all at my vertical displacement, which is +1. So I know that I need to put a dotted line there, and we'll do it in red just to make life different. So at +1, and just move it down a tiny bit. The next thing that I look at, it says -2. Now we haven't had a negative before, so that's important to know, okay? And we're gonna have to deal with that. But first of all, I'm interested in where it has to ping pong. It has to ping pong to above and to below our middle line. So again, we're going to draw that to above, so I'm at 3, to below, I'm at -1. Now sine starts in the middle and normally goes up, but because of the negative, it's going to make the sine function go down. So it still starts in the middle, but sine function has to go down. So we will change the color of that text. That's really important. The negative makes the sine function go down rather than up. Okay, so again, we'll do blue. So it starts in the middle, but instead of going up, it goes down first, then back up. So it still ping pongs the exact same way. It's just how we started the graph. Okay, and for negative 90, it would be in the highest point. Okay, so we have all our ping pong balls, if you want to look at it, our points done. And so now it's just a matter of drawing a nice smooth curve through them. We'll do purple. We'll make this look very, I'm not going to say festive. I think it's going to look a little bit wacky with all these red and purple. Don't usually go together very well. And there we are. And we put arrows on our ends. Okay, so the next thing we need to do is we need to finish answering the questions. Again, our domain is any real number. Our range is any real number, however, it does fit between a different location than it did before. And so y has to fit between our ping pong lines, which would be lowest point is -1, highest point is 3. So -1 and 3. Our amplitude is 2. We don't care that it's negative for stating the amplitude. And our vertical displacement is up 1. Okay, so lots of graphing for you to do.